All right, we'll get started. Thanks for coming, everybody. Chris and myself are going to talk about observability, getting started with observability in Drupal and using OpenTelemetry and Grafana. And we're going to go quickly, and we're going to go slow. Thank you. We're going to introduce ourselves, done that, talk to the challenges of Drupal and Islandora debugging and analysis. Our grounding experience with this is an Islandora, set of Islandora sites. Definition of observability, real-world example of investigating a performance issue, components in an OTel stack, and a couple of other things. Sorry. Can you see that? I'm going to swap sides with you. Okay. And present some resources for further learning. Sorry. Let's continue. So Catalyst is a New Zealand company with a global impact. We work with a range of open source tools to deliver solutions for customers in government, education and enterprise. This asks of us expertise in operating a range of technology solutions, and fundamental to that is being able to understand how a system is operating in production and in local dev. I'm a senior developer at Catalyst. Jonathan is too. I'm based in Ōtepoti, Dunedin, and Jonathan's based in Christchurch. So Drupal stacks are often getting increasingly complex, right? It used to be just kind of your PHP code and maybe a database. But now often you've got a search component like Solr, or you might have front-end cache like Varnish or Redis. You might have other components. We do a lot of work with Islandora, which is a digital archive system that comes with a suite of microservices. So if you spin that up in Lambda or something, you're getting like 15 containers, and they're all spitting out logs and metrics and so forth. So increasingly complex architectures. It can be hard to diagnose a fault, especially if you've dispatched an event to a microservice and what was the outcome of that? Did it get did it complete successfully? Did it need to be retried? That kind of thing. So, especially in the case of Islandora, uses a separate component to transcode videos or generate image derivative. And if that failed, then where's the data for that? What can the operator do about that? Just a wee sidebar, I want to mention SPX because we found that very useful to diagnose a problem for a customer. SPX is kind of observability adjacent. It's not an observability tool per se, but because it can give you a really good profile and flame graph of your function calls, it's really useful to find what part of the system might be operating slow. So we had a customer with Solr Search API and Search API Solr, but some of the search results were taking 30 seconds to return, which is obviously a problem. So to try to figure out or get some handle on where in the system that slowness was coming from, we could fire up SPX, and there's a few notes there about how to load it in. It's a PHP extension, so it hooks into PHP, so you can spin that up in Docker. You can then, if you go to the admin page, and this has just got I'll show you a quick animation of that. But essentially what we saw was there was a 2-second per result delay, and it was coming out of the theme layer. And when we investigated that, we found there was an access control check looking into the database in the theme layer, and that was a really expensive access control check. So if we refactored, there was a contrib theme, by the way, so we didn't expect to find that kind of code operating in the theme. But once we eliminated that access control check from there, we got a good result. So that's where to get SPX. And this just shows quickly how you get this flame graph, and you can drill down on that to find particular functions and how long they took. So it's giving you the end-to-end span of time for a given function. And this is the resulting flame graph, and you can see that we've got I think it was 15 results there, and each result is essentially taking 2 seconds, and when you drill down on why that result took 2 seconds, it's because of that access control check. So one of the main things, but one of the issues there is this can be amazingly insightful if you want to get a handle on what Drupal's doing, and it's pretty fascinating, but that screen is essentially a visualization of 2.3 million function calls, and that generated 57 meg of data. So that profiling at that level is probably not practical for most things, especially not a production site.
So observability is described as having 3 pillars: metrics, logs, and traces. Metrics are the quantitative measurements of like how, where the needle is on your CPU. Logs are structured and time-stamped records of what happened, and then traces are a deeper, described as a wide event, which you can attach arbitrary data to, and so it's like a log entry, but with a lot more information about the context of what was happening at that point. In the past, we've had application performance monitoring tools like New Relic, Datadog, those still exist, of course. Open tracing, OpenTelemetry is seeking to provide, a consolidated toolkit. And the definition is an application's properly instrumented when developers don't need to add more instrumentation to troubleshoot an issue because they already have the information they need available. So some pointers here to building blocks of the OpenTelemetry project, which is an open source project, a PHP extension for it, a Drupal module which uses that PHP extension, Grafana's Alloy agent, which is an OpenTelemetry collector. It's an implementation of. So there's a kind of core collector as well, but I'm a fan of Alloy. And Grafana, which you can run locally, which you can run yourself, or you can run in Grafana's cloud.
So so the OpenTelemetry project's part of the Cloud Native Foundation. I think at Nick Shu's talk about observability last year, he mentioned that it's probably one of the bigger projects within that whole ecosystem. And it's essentially about building a non-proprietary agent that you can put on your servers, because one of the issues originally with things like New Relic is you need to trust their binary, which most of us won't. So the beauty of the OpenTelemetry project is that you've got a consistent definition, consistent agent that you can put on your servers that's vendor neutral. And the whole idea is that it can then communicate using OTLP, OpenTelemetry protocol, to ship metrics, logs and traces out to whatever destination you have in mind, and that could be a local instance of Grafana, a cloud instance of Grafana, or it could be New Relic or Datadog or Honeycomb or any of the numerous providers out there who are happy to host your OpenTelemetry data and give you some kind of visualization and analysis tools. So how do you get working with it? First you need the PHP extension on your server or servers. Well, this is talking about getting OTLP out of Drupal. Bear in mind that you might need other extensions or the agent to operate on Java or Python or whatever other systems you've got, Nginx, etc. So this is just how to get it out of Drupal. So you load your OpenTelemetry into your PHP set of modules, and then you can confirm that that's installed properly using PHP info. This is if you fire up the OpenTelemetry contrib module, then you tell it where you're going to send your OpenTelemetry. So you could actually put a Grafana Cloud endpoint directly in there and just ship straight from your Drupal instance straight into Grafana Cloud. But typically you'll want to route it through something like the Alloy OpenTelemetry collector, because that way you're going to scale better, and you've got local debugging, etc. of your OpenTelemetry. And it gives you a lot of configuration in terms of, we'll talk about in terms of logging and sorting out timestamps and that kind of thing. So the main thing is you've told it the OpenTelemetry endpoint. You can turn on debug mode, which just fires out a status message every time it generates a trace. You can give it a service name, which might just be Drupal, or it might be something else. And basically, it comes with a couple of sub-modules where you can choose to trace every incoming request to Drupal. You can also trace the databases and only trace on. This is just what it looks like, the UI for the OpenTelemetry module.
So the Alloy agent, I'm a huge fan of if you've tried to debug a system which has log files from different applications across different servers. Alloy is a tool which can help you collect and coordinate those and transform them into something that you can look at together in a much more coherent way. It's a vendor-agnostic way to receive, process, and export telemetry data. It feels like all of the Orkin said and modifying a log stream tools you might be familiar with. It's a pipeline for OpenTelemetry data, and not just the log data, but all data. So it can modify and process it, drop or enhance it, maybe changing the timestamp on that one server that's got the wrong timestamp to align logs. You can label, you can use that to support discoverability and reporting, and you can also ingest an existing app's logs by pulling them down, dropping them into a folder, and then using that, which is for adding this to an existing production stack has been a useful way to kind of use Alloy to analyze the tool without modifying production at all. This is a screenshot of Alloy's web user interface, and it's a pipeline that we were using for some Islandora logs where, as I was mentioning before, we had very different format log files from different applications, and we needed to process them into the same basic shape. What's shown in the top row is log processing and tagging to read those log files. What's not shown there is a ridiculous amount of timestamp handling. And yeah, once you get them into Loki, so from Alloy to Loki, then you can visualize this data in Grafana. Grafana's a user interface for the data that you're collecting. It's not the only one, but it's a very good one, and you can run your own. You can start with Grafana Cloud as well. They have a free tier with like 14 days of storage. I'm not sure what the other limits on that are. Mostly I've been working in a local environment for it. You can provision Prometheus for metrics, but I also use CollectD to bring metrics in as well. Loki for logs, sorry, Prometheus is storage. Loki for logs and Tempo for traces, and then you modify your config Alloy to wire it all up.
So as we talked about the three pillars before of observability, so metrics, logs, and traces. So these are all known in OTel world as signals of various kinds. And an example of metric is, say, number of Apache processes, for example, logs from your application or your hosting environment, and traces across, your Drupal application, Solr, whatever it might be. And the thing about traces is you can attach additional data to those, so it's not just timing data. And a new kind of signal that's in alpha stage at the moment is called profiles, which is closer to the SPX kind of.
So metrics is your qualitative, your numbers, what's going on right now, CPU, number of Apache requests, how many things you sold or users registered, any of those numeric moment in time measurements. Is this you or me? This is not a chart. So gathering metrics from Apache's mod status, which I think Jonathan just described. You're enabling it in your some Apache configuration on the bullet points to bring it in, and then get Alloy to pull that data out and send it off to Prometheus. Here is a chart of some metrics from a development environment. What can we see here? We've got Apache accesses, CPU time, CPU load, request duration, scrape failures, which we have none of, and some other charted values. These are system metrics. This is probably from CollectD and just showing quantitative numbers over time for operating system.
And one of the things you can do with the OpenTelemetry stuff and the OpenTelemetry module in Drupal is you can ship specific metrics, custom metrics out of Drupal based on whatever you care about. So if you're an e-commerce store, it might be what products are shipping. If it's an event, you could be tracking, have a dashboard of how many people have signed up for your event, that kind of stuff. And so one way of implementing that is fire up the OpenTelemetry metric submodule and then define your own. In this case, I'm attaching it to a event subscriber, which is going to fire on kernel finish request. So just at the end of a page load, it can run off, generate, in this case, a node count. So something pretty trivial. You can just see the example of the code there where it's using the OpenTelemetry SDK to create an observable gauge, and then it uses a function to go get the number out of the database or wherever you're going to source the details from. And then you can see that that gets shipped into Grafana and shown in a dashboard.
So logs are my life sometimes when we're solving problems, and this is collecting logs and putting them together from disparate systems, where you can, instead of using ways of slicing and dicing them together by hand or using a tool like Multitail, you're able to visualize the log entries with the time sequences of them happening. Yeah, so you get a better idea of what happened at the time of whatever incident you're looking at. You can zoom in and out and really zoom quite close into the moment of something happening to better understand what's going on. Not shown here, but logs, once you add tracing that follows a request right the way through a system, then you have a better way of visualizing an event as it's carried through in the log files as well. This is the OpenTelemetry logs module, which you can turn on from the OpenTelemetry module earlier, and then collect your Drupal watchdog logs or DB logs into Loki as well. File ingest. I didn't anticipate this, but once I realized that I could pull logs down and use Alloy from a local environment with production logs, that was a really helpful insight to being able to better use this tool and test how the log processing works. So it's a really good way to get started because you already have logs from your production environments. You can then use that configuration to deal with live ingest later. And you can start small and iterate. And I was absolutely stunned by the number of time formats across every different log file. 12 currently in this configuration. Who would know? So make up new time formats, go. It uses Go time parsing to interpret logs. I'm a fan of how they do this. There's a magic date in 2006, and then you just describe the way that date would look, and Go will go, oh yep, so that's what this date means. There's a URL on there for you to test your time formats out if you're like, how does this work? And then you can say, bring a log in, tag it as being an Apache log, and then run the timestamp processor and say, for logs labeled Apache or this other one, apply this time format, then pass it on to the next stage in the pipeline. It's not unlike Drupal Migrate for the kind of step definitions and YAML processing, but it's not YAML, but yeah, it's a declarative processing pipeline that allows you to reshape the data, which I'm a fan of.
And from my point of view, I mean, to my mind, metrics and logs, I mean, you may have those already. They may not just be as accessible if they're not inside some observability environment. But to me, the thing that adds a lot of value is the ability to start doing tracing. So when a request comes in, you've got a baseline trace across the whole request response. And then you can start adding individual spans within that cover certain function calls and so forth. So in my case, again, looking at Search API and Search API Solr, want to get a sense of, out of all the processing that's going on in building a search response, how much of that is Solr actually taking up. And again, you can, in this case, implement a local custom event subscriber. This one's wrapping the Solarium event subscriber. So Solarium is the underlying PHP library that Search API Solr uses to talk to Solr. And essentially, when the event fires, it gets the local request context from OpenTelemetry, and it generates a span. And then when so it starts the span just before it does the request out to Solr. And as soon as Solr responds, it closes the span. And once you generate that data, you can ship it out through Alloy to Grafana, and you can see that there's the end-to-end request, which took about 4 seconds, and within that, the Solr request was 248 milliseconds. So you can see that Solr itself, as a Java application, is only taking up a fraction of the time. So if you want to speed up your search response, clearly you need to look elsewhere, because Solr is already pretty performant. The other thing there that I didn't really show you, maybe, is, you can see the bottom line of that first code block. We're attaching the raw Solr request data. So not that this is a live demo, but if you were to click on this inside the Grafana UI, if you click on that Solarium span, I can then see all of the raw data that was going out to Solr. So you can attach arbitrary context and arbitrary attributes to those spans. But you don't necessarily want to have to add an entire event subscriber every time you want to attach, just look at a single function. That's not really scalable. So OpenTelemetry does support a degree of auto-instrumentation. Essentially, we need a patch. And as part of the PHP ini, you can register pre and post span hooks. And then you can just add a with span PHP attribute to a function anywhere in core, for example. Say, oh, I want to start getting spans out of this function, like view execute, perhaps. How long is that taking? So basically, if you go add that with span attribute into that execute function within the view executable class, then you can start getting span data. You can now see it's got view executable in the execute function just above the Solarium execute that I already had in there from the event observer. But again, that still requires you to change core. So you'd have to do that through a local patch or something. There's another way of getting into it, which is OpenTelemetry instrumentation hook, where you can specify any class or function and say, fire these pre and post functions, start my span and close my span anytime that gets invoked. So that allows you to instrument core from contrib without having to change core. And again, the question is, where do you declare that hook? It might be as part of Composer auto load, or it could be an event subscriber. This is just an example of hooking into the view executable get display function. And I'm doing that inside an event subscriber that's happening very early in the request handling in Drupal. And again, this is just looking at a single class and a single function, but there's no reason that you couldn't use reflection or other methods to gather a whole bunch of core classes, a whole bunch of functions, and then start pre and post span generation for each one. So this just shows the same thing. We've added the get display spans for the get display. So that just shows you 3 different ways that you can generate these spans out of the Drupal environment. I just also want to mention that, as well as the whole definitions around metrics, logs, spans, OpenTelemetry also defines a bunch of semantic conventions, and that just means there's common definitions of how to label a HTTP status code or server name or service name or request duration or whatever. So it just means across the whole OpenTelemetry stack, tooling, across all the languages, there's some common labeling for these things. So it just makes life a whole lot easier once you start aggregating data from diverse sources. Yeah, so just a few issues and challenges. So you can do automatic instrumentation that currently, actually it's old, that's supposed to be commented out because there is that patch and it's working now. Tracing microservices need to have identifiers in there to make sure you understand where everything's coming from. As Chris mentioned, so many different date formats and logs, so that's a pain and good to share if you have a format that works. One of the issues here, especially if you are shipping out to a cloud aggregator, is what happens to private information like email addresses or IP addresses or anything else that's sensitive, any secrets. You need to be careful about that. And I think there's some solutions in the pipeline, but just be aware that there's some challenges around OpenTelemetry and with fibers. That just makes life a bit more complicated when you're tracing. Just got a list of resources there. These slides are already available, so I'll go back to the start and you can grab the URL for the slides. But there's some good videos online about just observability in general. The OpenTelemetry Drupal module is by Alexei Koropov, who did a talk a few years ago in the early stages of that module. And yeah, some good books as well around if that's the way you like to get your data. And the link at the bottom there is a link to one of Chris's repos for standing up a local Grafana in Lando.
It's based on there's a DDev plugin for observability, and it builds on that to have the same set of services and some few extras, and then you can see there some of the date processing and other pipelines that we've been fooling around with.
So yeah, that's the end of the talk. I'll just go back to the start so you can see the URL if you want to get hold of those slides, and we might have a minute or two for questions.
Hello, that was fantastic. I've been looking for, hovering around the OpenTelemetry space, wondering about how hard it is. I'm glad someone's done a lot of work on it. We run a decoupled site, a large decoupled site. And did you say you've implemented that and done some work with getting end-to-end observability?
Well, just by default, the OpenTelemetry module will give you the end-to-end request as soon as it hits Drupal. You would need to start your trace in the JavaScript zone if you're coming from an SPA or something. But the whole idea is that can then propagate. We didn't really talk about the whole idea of the tracing is that you can then put a trace identifier into your outgoing HTTP requests, and that's how it can propagate through a whole stack. So yeah, but that's all in the OTel docs. And one of the other things we didn't really talk about, but Grafana offers, and so do some of these other providers, but the real user monitoring stuff. So you can essentially get out of using JavaScript, you can essentially get real-time, the kind of data that you see in Google Lighthouse in terms of contentful panes and all that kind of stuff. You can get all that data in real time for every user.
Through OTel as well?
Yeah.
G'day. Haven't been a while. I've noticed for a while the traces and profile are usually rather expensive in payload and size. What are the specific challenges of using Grafana?
I would go towards sampling for like not tracing every request. So tracing a number of is a way to get some data, but not all of the data, because yes, there's a lot, and that's also where the P2 note comes in. There's so much information that's readily available, like it was always available through log files, Well, some surprising amounts of data were always available through log files. Now we have this observability, and you can easily have too much data, whether that's from a business perspective or from a, just the amount of data. So sample small or sample targeted is the only answer I have for that.
I mean, just because I happen to know it off the top of my head, there's a recent RFP from our Accident Compensation Corporation for an observability solution for the enterprise, and they talk about having a couple of hundred containers in production, a couple of hundred non-production, and a similar number of VMs. They're talking about generating 650 gig of logs a day, and they want to have 30 gigs held for 2 years. So you can do the numbers on. But that's at a large scale.
30 gigs a day for 2 years?
Yeah.
Okay.
Yeah.
This sort of stuff has been my life for too long now. I'm working with Blackfire, if you're familiar with that, does a lot of the very similar stuff. I want to ask about how you've been using it in practice where the rubber hits the road. In my experience, when there's a performance issue, it only happens on the live site under load. And those sorts of situations are hard for us to just go in and start patching and adding hooks, etc. Like the live site is the finished product. So I'd just like to hear what you've used it for in a client website or a real case scenario.
Practically, the use has been from log files for production environments. Jonathan and I haven't put observability into production for traces. Logs and metrics we've used. And since we already had that data, but in a different environment, it was helpful to consolidate and make coherent and make it possible to look directly into what's going on where an incident is happening, where previously you would have been collating and doing a whole lot of work beforehand to make that available, or trying to calculate. Multi-tail's great. You can look at several log files on screen and kind of freeze frame, but it's a bit desperate. So that practically it has been helpful. It's helped us find things that we didn't see before because it was too hard to look. Yeah.